So let's start our discussion about deployment. And for most people, unless you've been in an internship or unless you've sort of operated a piece of software that you yourself created, this is starting to get into the area that probably most people taking this class are less familiar with. And it's the differences between your view of software when you're developing it and running it on your own computer and so forth, versus your view of software when it's actually deployed for others to use. And of course, in the case of software as a service, that means it's deployed in the cloud and potentially anybody can access it. So what are the big differences? Start with the big picture here. Development versus deployment. How does that change your view of software development? Users are a terrible thing. Your software is so good when the only person using it is you, and you sort of are using it the way that you designed, and you sort of have your scenarios where if I do this, then that happens, and it makes you feel great. And then actual normal users come to use your software and they do all kinds of things you never thought of. And they destabilize it and they expose bugs that you didn't have. And you tell your users, you shouldn't have done that. But they're users and they do that. Some bugs only appear under stress. I'll have a personal anecdote about this in just a little bit. But there's a lot of things that only go wrong when lots of users are hitting the app or when the app is under significant duress for other reasons. And those bugs just won't manifest. They don't manifest as correctness issues, the kinds of things you would notice and create tests for in your development environment. There usually are some differences between your development environment and the production environment. Sometimes there are differences only of scale. The production environment has faster computers, more of them, more copies of the app server could be running. But there may also be differences of the kind of software. For example, Heroku, which we use in this course for deployment, has a particular version of the Postgres database that they host, and they have it configured a certain way that makes it really efficient for a lot of different Heroku apps to share one large database. That means that it's probably configured somewhat differently than the way that you do your development, even if you're using Postgres for development. So most of the time, there are ways that you can mitigate and sort of try to mask those differences, but every once in a while, something that's different between production and development will unexpectedly arise as something you need to pay attention to. And finally, deployment is about what happens when your app is used in ways that you never meant it to be used. And there's sort of two ways that can happen. One of them is that there are bad actors out there, and most bad actors don't necessarily care about getting the data that's in your app, unless your app is extremely high profile. They're probably more interested in using it as a vector for delivering malware or recruiting it as part of a denial of service attack. So even if they're not interested in what your app does or going after your customers, you still have to be mindful of ways that it could be misused and what you as a developer can do to thwart some of those bad behaviors. And also, the world is also full of people who just kind of don't know what they're doing. They will sort of throw random data at your app. They'll click where they're not supposed to click. They'll enter negative numbers where they're supposed to enter a payment amount. So a lot of things that, you don't think about them until you actually witness what people are doing when they use your app in the wild. So the good news is that deployment has gotten a lot easier than it used to be. If I sort of divide computing into, the early ages, the middle ages, and if we call, right now the sort of modern or postmodern period, the sort of early Renaissance was the early 2000s. The web was a thing. Web services were everywhere. Web 2.0 was what everybody was talking about. But really in those days, to deploy an app in the cloud, you essentially had to configure your own virtual private server. So essentially a virtual machine that is a slice of a piece of hardware somewhere, but it's basically a bare bones, probably Unix-like box, probably in the cloud. Starting in the late 2000s, AWS, Amazon Web Services, made it much easier to do this because you could sort of instantaneously just pay by the hour, but you were still getting essentially a machine where you would have to install and configure everything. You started from a sort of bare operating system. You'd have to install the software frameworks you wanted, a web server like Apache. If you needed a database, you would probably install something like MySQL because it was free. You'd have to make sure that OpenSSL was installed because we need secure connections. And OpenSSL has a vulnerability like every couple of months. And so you have to reinstall and recompile OpenSSL. And that breaks everything else because they depend on the earlier versions. And you would be in library hell. And you would spend all your time doing stuff like this, fixing vulnerabilities, addressing problems of software maintenance, trying to tune all of those things so that whatever hardware you're paying for, you're getting the most efficiency out of that hardware. And finally, if you want your app to be able to respond to surges in users, you'd have to figure out how to automate horizontal scaling, which we'll talk more about in a minute. So you'd have to do all of that stuff which, by the way, has nothing to do with what your app does. This is just like the plumbing and mechanics and infrastructure to allow your app to exist at all. So it's not like your time on this adds value to the app. It just prevents bad things from happening. And then on top of that, damn it, you have to deal with users who are going to come along and break your app by doing things that you never intended. So this sort of collection of things, and those of us who are around in these days and remember what it was like to operate your own deployment stack, it's one of the reasons that we have very wholeheartedly said platform as a service, or PaaS, which is kind of what Heroku provides. Like, just pretend it's a Git remote. You set up a few things using a GUI, you push the button, and bingo, your app is live. And you didn't have to configure the database. You didn't have to worry about the web server or SSL. This makes a lot of those mechanical problems on the previous slide just sort of go away. And it handles some of the sort of what I'll call the easy aspects of horizontal scaling. We'll talk about what that means in a moment. It handles dealing with component level performance tuning. There are people at Heroku whose only job is to make sure Postgres runs really well. They're going to do a way better job than I would ever do because I'm not a specialist in Postgres database administration. So not only are they hosting things for you, it's in their interest to get bang for the buck out of the hardware so you don't have to do that. They also deal with a lot of infrastructure level security things. For example, if there's a security vulnerability in SSL, which we're going to talk about a little bit later in this section about SSL, that secures the connections between users' browsers and your web server, normally, if you were running your own site, you would have to patch that vulnerability probably by downloading and recompiling one or more libraries. In this case, that's done for you, and it's usually done quicker than you would have time to do it yourself. Now, that doesn't mean that you don't have to do anything, but it lets you focus on the parts of the app that are important, the places where you as a developer can make a difference to make your app highly performant, to protect your customers' data, to be able to handle load surges. So you can now free yourself to think about, in terms of design, how do I minimize the load on my database so that I can get more mileage out of it? In terms of design, what can I do in my app to improve the performance as seen by the user? And therefore, I have to pay for less hardware, right? The more usage I'm getting from the hardware I pay for, then the more users I can serve spending the same amount of money on hardware. And rather than worrying about infrastructure level security and SSL libraries, I can worry about what are the ways that people might try to use my app as a vector for doing something evil, and how can I focus on identifying and mitigating those things? So I've had a lot of students who are designing a project, or they have a project in mind, and they will come out of the gate with something like, I know SQL databases are not scalable, and I want my app to be really scalable, so I would like advice on which NoSQL database to use. I usually remind them, Pivotal Tracker, which is one of my favorite web services we've talked about earlier. It's great for tracking user stories and work in your software project. There's hundreds of thousands of accounts and millions of projects in Pivotal Tracker, and that runs on one database, one big box. It's administered by people who know what they're doing, but it's basically a box that costs less than $10,000. So you have to get to that level before you start saying, oh, the platform as a service is not going to be enough for the needs of my app. It's not performant enough, or it's not scalable enough. Right? I think views of scalability, unless you've actually really sort of been in the trenches and, had to deal with millions of users, most things are more scalable than people realize they are. And one of the nice things about software as a service with this PaaS model is it makes economic sense to develop something that is designed for use by a very targeted customer, right? Your customer might be a nonprofit entity that's got 30 employees, and maybe those 30 people will be the only ones who ever use the app. But it's so relatively easy and inexpensive to deploy that it actually makes economic sense to do that, right? Rather than having them use some piece of software that doesn't really match what their business needs. So because of that, a lot of sort of very valuable SaaS apps, they're not valuable because they do a small number of things for a lot of people. They're valuable because they do a large number of things for a small number of people, and they do it in a very specialized way. And platform as a service is a great fit for that and makes it totally feasible. And even if you become convinced that at some point you're going to outgrow everything that Heroku can provide you, or that it doesn't make economic sense, a really important insight is the same things that you're going to need to solve if you go it alone and if you abandon platform as a service, those concepts and the techniques are exactly the same ones that you would need to use to get the most out of the platform as a service that you're using now. So there's sort of no free lunch here, right? There's a set of design techniques about how to keep your app performant, scalable, secure. And regardless whether you're doing platform as a service or doing it yourself, you need to understand all of the same concepts and techniques. It's just that if you are using platform as a service, they will handle a lot of the details for you as compared to doing it yourself. Performance and security. We've now used those words a bunch of times. What do they actually mean? Let's start with availability or uptime. That seems like a pretty simple definition. What percentage of the time is your app up and accessible? So, a user tries to access your app and do a request, they're able to successfully do it. Responsiveness. How long after the user does something do they get a response? Usually for web apps, the response is something they can see. They see a page that's displayed or some visual clue that something has happened. Scalability. There are many definitions of scalability, and we'll come back to it. But I think most people, when they talk about a web app scaling, what they really mean is, as you get more and more users, can you maintain roughly the same level of responsiveness without increasing the cost per user, right? And pretty clearly, if the cost per user increases as the number of users increases, pretty soon you're losing money on every user, and who wants that? Privacy. Is data access limited to people who should be able to access the data? Who might try to get it? What loopholes or security holes might they use? And how should you as a developer be aware of that? Authentication. This is more important for some apps than others, but in general, it's, can we trust that the user is who they claim to be? Most often, it's because certain users have different privileges than other users. And so depending on what the user's identity is, that may determine what they are allowed to do in the app. And finally, data integrity. Even if someone is not trying to steal the user's data, if someone is trying to tamper with the data, can you detect that the data has been tampered with, or that if, for whatever reason, it's not the same data that the user originally sent? I'm going to sort of generally group the first three of these into what I call performance stability, so performance-related issues, and the last three into what I would call security-related. So there's many angles from which you can talk about performance and security, but this is a sort of representative collection for software as a service, and it's the ones we'll mostly be talking about.